Good evening. Oh, turn the speaker off first. Here we go. Good evening. This is VK3 Echo Kilo Hotel, VK3 EKH, the official station of the Astronomical Society of Victoria with the regular Friday night broadcast. Coming to you from the studios of VK3 CSJ in Narre Warren South. A very pleasant good evening to everybody here on this 21st of March. Trust everybody is well and in good health. We are transmitting on the prime frequency of 3541 kilohertz in the 80 metre amateur radio band, and also by the Melbourne television repeater VK3 RTV digital channel 1 on 445.5 megahertz DVB-T2. All information about the repeater can be found at Amateur Radio Victoria website, ARV, Amateur Radio Victoria website. Just look for the information link to RTV. Is one dedicated page to it all, how to look into it, how to see it. It's also VK3RTV.com is another website. And we're also transmitting or streaming on my Discord HD channel, as I've said every week. Just go to Discord, register if you haven't already, and you get a password or some access to it. And if you go to my QRZ.com page, VK3CSJ or VK3EKH, I provide a universal link to be able to see, to go to the chat room as well as see the HD video stream. And as I mentioned every week, the video stream is less than a second delay between what you're hearing of me on 80 meters right now in real time to what is seen on Discord, which is far better than YouTube. But apart from all that, yes, we are streaming on YouTube. My channel is VK3CSJ, and just look for the live indicator, live symbol. And hopefully for the next 60 minutes, the modem will hold up, it won't fall over. So far, traditionally, it's been good for the whole hour until I do the callback, and then it decides to fall over. So bear with us for this next 60 minutes, and hopefully it'll hold in. Because if I lose YouTube, I also lose Discord. Anyway, we'll get there on that one. But nevertheless, all right, we've got a few interesting things tonight that I've found along the way this evening. And basically we're going to start off by running down excuse me, with the Astronomical Society of Victoria. Then we'll recap the SpaceX capsule return, followed by an interesting article on why spacecraft carry magnetometers, followed by a story on nuclear batteries, or i.e. radioisotope generators. And then that will follow a recap of Firefly, the lander, Firefly's Blue Ghost lander. Some interesting footage is involved in that one too, because it's all HD. All these missions to the moon now are in full HD, and what's coming back, even though some of these missions have failed, I mean the electronics has still functioned, and some of the video images just outstanding. So it goes to show that coming up in the near future, when we do finally get back to the moon and Mars, for that matter, all the footage that we'll see will be not as blurry as it was with the Apollo missions. So fantastic stuff. And if I've got time, there's another interesting article on a new lens. It's a game changer. Followed by spaceweather.com. Righto, Mr. Brash. There is an email address if you wish to send signal reports. VK3EKH at VK3EKH at gmail.com. Start again, VK3EKH at gmail.com. And I just better make sure that that's in fact working. No, it wasn't. So I shall just go across to that inbox so I can just keep an eye on it. Alright, so that's open. And I think that's about it right now. So we'll see you all next week. Alright. Now, just trying to find some dialogue here. Where is my usual dialogue page? There it is. You're tuned to ASV Radio, VK3EKH. The ASV is a non-for-profit society for people interested in astronomy, attracting and catering for people from a wide range of ages and backgrounds, abilities and interests. First formed in 1922, the society has grown to over 1,000 members. Its activities are coordinated by a council of elected office bearers, section directors and ordinary councillors. The ASV has weekly activities at two metropolitan locations, the Morley Community Village and the Melbourne Observatory. It's we also host a monthly Astro Talks, which I now try to transmit by the television repeater every on those monthly Wednesday meetings. Last Wednesday, was it this Wednesday? No, last week was a really interesting presentation. I just forgotten the fellow's name right now. Let me see if I can quickly find that. It was... No, we're talking about... No, where are we? That's March. Yeah, March. Astro Talk. Here we are. So that's of course. And that went for actually over an hour, that presentation. It's all online. You can view it again and again and again. The Anatomy of Award-winning Astrophotography by Benjamin Aldridge. And Benjamin discussed his astrophotography, drawing on his experiences as an internationally recognised nightscape photographer and the manager of far and away largest smartphone astrophotography community on the earth. Anyway, he gave an excellent talk, and his presentation was tops. Great pictures, good graphics, and certainly you walked away understanding a few things about astrophotography, which is something I'm wanting to get into. That was last Wednesday, and of course that went to YouTube and also ASV Facebook page. But I picked up the YouTube feed and rebroadcast it, so that's what I'm getting into doing now when they do this Astro Talk thing. Apart from all that, yes, the Society's library is also located at the Melbourne Observatory and is open during our Astro Talks too. For over 50 years, the ASV has played a major role in the care of buildings and facilities at the Melbourne Observatory. Our members conduct astronomy for the people gatherings, or sidewalk astronomy is the American term for that. But it's pretty much the same thing. Our members conduct astronomy for the people gatherings throughout the year, bringing telescopes and astronomy to Melbourne's parks and schools. They say here to check the online calendar for when these events are occurring. They are open to the public, so of course when it's in the middle of a park somewhere, members of the public can come up and have a look through telescopes and see the sky that they can't see with their naked eye. The ASV is currently involved in a number of major projects, and we are involved in the restoration of the Great Melbourne Telescope, and are also currently working on the installation of a series of remote telescopes at our dark sky site up at Heathcote, which are pretty much all done and dusted actually. Thanks to a generous donation from one of its former member, the late Leon Mao. He donated the dark sky site up there to Heathcote to the ASV, located north of Melbourne, and has a pristine night sky for deep sky observing. Although we are slowly getting encroached upon by light from Bendigo, the greater Bendigo is getting greater every year, and the inevitable glow from Bendigo is predominant on the western horizon, but it doesn't disturb the viewing. Alright, and a little bit of glow from Heathcote itself, and if you look hard enough you might also see the glow from Melbourne, but it's still pretty good. It's very good viewing. There's also an annual yearbook published by the Society. Viewers on the screen here, this is the yearbook. It's quite a substantial little publication. That's for 24, but I've got the 2025 around here somewhere. But it's like an almanac of sorts, and ideal for optical astronomers that might need to for a quick data and things. I'm just trying to open up the book in front of the camera here. It's a bit difficult, but you can see here there's all these interesting data and things for astronomy. So that gets sent to you once you become a member. There's also a bi-monthly newsletter which we call Crux, and that's this is the August-September edition that I'm holding here. Only because I've only got that because it's just been sitting on the desk here for all these months. But that's the Crux newsletter, and really quite amazing stories in there, nice and glossy pictures and beautiful publication. So you get that too, and that's the little logo that ASV has, showing it on the TV. So this program I do every Friday night does really rely on the video side of it, so that's why I recommend the YouTube side of things and Discord and the TV repeater, of course. Okay, what else? The logo, the ASV logo, which shows the Southern Cross, which I just showed just a moment ago, that's it there, has a motto, which is some Latin thing, which I just will not try to pronounce. But otherwise, the English translation of the Latin motto is that it is this way to the stars. My God, it's full of stars. This way to the stars. So excellent stuff. The ASV is governed by a set of rules which should be read before applying for membership. This document may be downloaded by clicking here. I'm not sure if that link works. I say that every week. Any person or organisation with an interest in astronomy may apply for membership of the Society. Join now. It's PayPal, easy peasy Japanesey, and yeah. So all information is on the webpage there for joining the ASV. Now there are several sections, more than several sections that you could be interested in. These are individual groups that hone in on the various aspects of astronomy, and that is astrophotography, club section, comet and meteor section, computing section, cosmology and astrophysics, deep sky, historical section, instrument making for the juniors, lunar and planetary, new astronomers group, radio astronomy, solar astronomy, and space exploration. And there is another section there somewhere that's suddenly disappeared off the list here. There was one for the ladies in astronomy, dedicated sort of section for the ladies that want to explore the sky. I'm not sure what's happened to that. Why is that disappeared? People, there was that section there. Anyway, all right. So all that information is on the website. Each when you go click under sections, you get those various sections, and you click on that, and it opens up to another page which describes what they do. And if you're interested in anything that's involved there, just get in contact with the section director. If you're a non-member, he'll be happy to be invited in for a meeting, whether by Zoom or whether it's held somewhere. And from there, the section director can discuss about what's involved in becoming a member, if you're interested in staying on. All that sort of stuff. The ASV website is www.asv.org.au, www.asv.org.au, and all will be revealed. So there it is, the Astronomical Society of Victoria. Getting bigger, both in membership. I think it's now 1,800 members all up, and we are now amalgamated. We amalgamated with the Bendigo District Astronomical Society some time ago. Shepparton Astronomical Society is also part of the ASV now, and the Geelong Astronomical Society is now also a part of the ASV and they also have their separate sections as well. So all excellent stuff. Okay, there's a few things coming up also in regards to coming up events. A weekend under the stars, March 28 to March 31. There's Envelope under the stars, March 21 to 22. And it's been and gone. Stellar Nights at the Melbourne Observatory. There's some new dates coming soon, so look out for that. But your chance to get a look at the Melbourne Observatory, they refer to that as Stellar Nights. Join us for a tour of the sky through Melbourne Observatory telescopes. And what was the other thing? Oh yes, the Mildura Star Party, Anzac Day long weekend, 25th, 26th of April, not too far away. So that's the Sunraysia Gliding Club Airfield, Mildura. There's a star party up at the Mildura Sunraysia Gliding Club Airfield. So and there's information. I'm looking at the browser on the main website. All this is on the main website page. There's a revolving banner. And what was the other thing? Seeing Stars. See You in the Cosmos. That's June 28. June 28, 7 p.m. to 11 p.m. Yep. And then there's another event, Sea Star Giveaway, which is not so much an event, but it's a little. I suspect you'd have to be a member of the society with this one. But I don't know. I'm not sure if I've spoken about the Sea Star. But it's a special, portable telescope. It's a very compact miniature telescope that can do some pretty great things. And ASV are doing a Sea Star giveaway. Join the ASV. Well, here we are. This is the catch. Join the ASV between December 10, 2024 and December 10, 2025. So you've got all this year for your chance to win a ZWO Sea Star S50. Look it up on the internet. Go to your favourite search engine and type in ZWO Sea Star, as in sing, Sea Star S50, and have a Google of it. It's doing some great things. And then, of course, on August 9 to August 10 is the VASTROC, Victorian Astronomical Conference, Astronomy Conference. They're working on getting a vast number of people to do presentations there, so I'll keep you guys abreast of VASTROC and give you an idea of who and what is doing their presentations during that weekend. So it's a good just to sit there and listen to these blokes talking to you about their experiences. All right, that's enough of that. I really have dragged out the first 20 minutes. So there it is, the ASV and quite a few events that the Society is putting out there this year. Wine Under the Stars is another event. Wine Under the Stars is slated for May the 3rd and is between 7 p.m. and 11:30 p.m. So again, all this information is on the main page of the ASV, and you can send an email. There's a contact under About Us, and to the president and or whoever, and the secretary perhaps, and they'll let you know what the score is with all that. You're tuned to ASV Radio, VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast. All right, now if you haven't tuned in to the video side of this broadcast, I suggest that now is the time to start doing it. I'm transmitting on YouTube, streaming on my YouTube channel, VK3CSJ. Just look for the live indicator, and like I say, I'm hoping that my stream doesn't fall over. And also on Discord. And let me just have a quick look at Discord. Yes, we've got 100 people watching the HD channel, so that's really, really excellent. Welcome to Andrew. Welcome to Les, VK5KLD. G'day, Les. Stuart, VK3UAO. And our resident Mount Burnett Observatory astronomer, VK3KDM, David. And some fella just up the road. G'day, Mike. All right, that's looking good. I didn't look at the chat room though, and let me see my emails. Yep, Dave is there. Mr. AIF, g'day Dave. Haven't heard you for a while. And what are you saying? Signals sound loud and clear. YouTube a bit of a latency. Yes, well that's why I say Discord. Always, I mean, investigate Discord, because Discord, the video is less than a second delay, so unlike YouTube. All right, some of you may have noticed that our 3 astronauts that were stranded on the International Space Station, marooned for 9 months. They're only meant to be up there, I think, for 10 days, I think it was, but they ended up being there for 9 months, which I'm sure they appreciated one way or another. But yeah, there was a launch of a SpaceX Dragon Freedom capsule to not only pick up the 3 astronauts and a couple of others, to bring back to Earth. But also the capsule up there actually brought in a new bunch of astronauts to take over, which I'll show a photograph of them in a short moment. But I think this was Tuesday morning, Tuesday or Wednesday morning. I can't remember now, but I know Tuesday, perhaps. Yeah, I was at work, and my space.com little announcement on my mobile phone gave me the live indicator that there was something happening. So whilst working out of the corner of my eye with my earbud in my ear, for about an hour we watched this amazing landing of the capsule. So it was perfect off the coast of Florida, and they had beautiful conditions. The sea was almost a milk pond, and it was a 100% landing, so it couldn't have gone any better. Astronauts Butch Wilmore and Sonny Williams were safely brought home after 286 days in orbit. SpaceX Dragon Freedom capsule safely splashed down at the Gulf of Mexico, the Gulf of America, depends on the point of view, on Tuesday evening, bringing astronauts Barry Butch Wilmore and Sonny Williams home after the two spent 286 days in space aboard the International Space Station. The two, I think I said 3 before, the two were joined by Crew 9 NASA astronaut Nick Hague and Russian cosmonaut Alexander Gorbanov, who were also aboard the International Space Station during Wilmore and Williams' stay. The spacecraft returned to Earth at a scheduled splashdown time of 5:57 p.m. EDT, and NASA's teams aboard recovery vessel Megan began the recovery process shortly after. I've got a fixed image going on there, but I do have some video of this, which just goes for about 2 minutes. So let me just run that.
This is really such an incredible
and I'll kill the audio that's there. Don't need to hear the audio. Alright, so there's the astronauts, the 2 astronauts that were up there for 9 months, and the other two that were coming back as well. That's currently floating or coming down. They haven't quite hit the water at this stage. So this is live footage inside. They're all looking up at their monitors. There's these big flat screen monitors just above them, and they're all looking up, making sure that everything's running okay. But they've just dramatically slowed down from racing through the atmosphere at an incredible speed of a bullet. The plasma was building up around the outside of the capsule, and all of a sudden parachutes open and massive deacceleration, and here they are coming down for this absolutely magnificent splashdown. This is footage from a NASA drone. They've got this absolutely fantastic drone that's just floating there, and it's capturing this amazing landing. So Wilmore and Williams were left aboard the International Space Station for an extended stay after their Boeing Starliner spacecraft encountered helium leaks and thruster malfunctions during a week-long test flight to the station last year. In September, the uncrewed Starliner returned to Earth autonomously, while the 2 astronauts were left on the stranded station. Following the splashdown, the 4 space explorers were video recorded in what was described as a capsule full of grins after NASA's live stream of the recovery. All 4 astronauts were safely extracted from the capsule and transported to a recovery ship medical facilities for examination. Let me just go back to vMix, and because that footage is about to finish. What was interesting too is that while the people were coming up to the capsule to do measurements, they had to measure the atmosphere around the actual capsule itself, because the the fuel that's used for controlling the re-entry and slowing the capsule down leaves toxic fumes that can just be emanating from the capsule, and they're fairly toxic. So they've got these people that come in just to do a quick measure with particular instruments, of course, to see if these fumes are still lingering around before anything can be done. So this is what you're seeing right now. It also gives you a scale too. It was a bit hard to know how big this capsule was until somebody jumped aboard, and you can see the fellow there on the side. So you've got an idea how big this capsule is. But also, what's really interesting about this one photograph are the dolphins. There were a pod of dolphins that came up to welcome the capsule home, and I was watching this on my mobile phone, and there was an aerial shot taken from the drone. Looking down, you could see these pod of dolphins that had come out to welcome the capsule. I must admit, I got an apple in my throat when that happened. I thought, how cute is that? These wonderful creatures. It's just amazing life. Anyway, so there it is. Now, there was just something else to continue on with. Where was the other part of the story? NASA stated that during its live stream that the astronauts will be flown by helicopter to the shore in Tallahassee, Florida, then transferred to an aircraft to fly home to Houston. And of course, there's an image here of the new astronauts on board the International Space Station, the ones that were dropped off, so to speak. And this is the new crew. Everyone in blue there, I gather. Blue uniforms. They're the new crew that came up. And you can just see behind the two astronauts going home, because unfortunately there's a hand blocking Sonny's face, but you can just make out the two astronauts in the back there waiting to get into the capsule so they can come home. But yeah, just reading this other thing here. SpaceX Dragon spacecraft successfully docked at the International Space Station on Sunday, clearing the way for stranded US astronauts Butch Wilmore and Sonny Williams to return home. The Crew 10 mission arrived at the International Space Station around 29 hours after launch in Florida, carrying NASA astronauts Anne McClain, Nicole Ayres, Japan Aerospace Exploration Agency astronaut Takai Onishi, and Russian cosmonaut Kirill Peskov. A live stream of their arrival showed joyous scenes as they entered the International Space Station and embraced the Expedition 72 crew members, including Wilmore and Williams on board. What else is they're saying here? Of course, the problem was that NASA and Boeing had identified helium leaks and issues with the thrusters on the Starliner spacecraft that took the pair to the International Space Station as it approached the space station, leading the agency to decide to return it uncrewed to minimise the risk and gather data. Boeing's Starliner spacecraft safely returned to Earth in September, touching down at the White Sands Space Harbour in New Mexico. Wilmore and Williams have spent their extended time on the International Space Station supporting the station research, maintenance, Starliner system testing and data analysis, according to NASA. They will be joined by American astronauts Nick Hague and Russian cosmonaut Alexander Gorbanov, who arrived in September. So yeah, so there's the update in that one, and so far so good. Everything's moving along very, very well. All right, let me just find my camera. Somewhere up here, there it is. Now, the next story is to do with why so many spacecraft carry magnetometers. This is VK3 Echo Kilo Hotel. Righto. Now there's an image here of Voyager. It's a artist's concept, so I'll just throw this in for the mix while I'm talking about this. And there is a video associated with this as well. Yeah, what did I do? Oh, I see what I did. I was going from there to vMix. Where's my image? There it is. So this is an artist's impression. Hang on, let me get rid of that. Oh, there's me. And get rid of my other, there we are. Just the ID on the screen. Had the wrong ID on the screen. That's an artist's impression of Voyager, which has also got a magnetometer on board. Alright, so why do so many spacecraft carry magnetometers? Pictures may enliven us, but other data added to a huge amount to our understanding of the cosmos, as it says there. The public is enamored of images returned to Earth by space probes, whether they show the moons of Jupiter, the rings of Saturn, or the icy surface of Pluto. These captivating images garner loads of attention. Enamored. In addition to cameras, robotic probes always carry an array of scientific instruments that get far less attention from the media, but these devices provide critical data that space scientists use to expand our knowledge of the solar system and the universe. Among the most important instruments are magnetometers. As their name suggests, they are devices that detect and measure magnetic fields. But how do magnetometers work? And how is the information they gather useful? Many planets and moons and all stars generate magnetic fields. Earth's magnetic field, for example, is created by the movement of molten iron and nickel in the planet's core and helps to protect Earth from charged particles in the solar wind. If unchecked, such particles would destroy our atmosphere. The Sun also generates a magnetic field because of the motion of charged particles in the plasma of its interior. Jupiter's magnetic field is so strong that it's second only to the Sun in intensity. The region around a body where its magnetic field influences space is known as the magnetosphere. Jupiter's magnetic field is so vast that its magnetosphere extends out as far as the orbit of Saturn. So why do we study magnetic fields? The presence, strength and orientation of a body's magnetosphere can tell scientists a great deal about a planet, moon or star's composition and the interior, and can often be measured from a significant distance too. Magnetic fields themselves cannot be imaged with normal cameras, although anyone who played with magnets as a child can understand that they have definite shapes and variable strengths. When humans began to send probes out into space, they needed to invent new tools to study unseen phenomena, including magnetic fields. When designing a magnetometer, scientists must decide what aspect of a magnetic field they want to study. Some magnetometers measure the strength of a magnetic field, while others detect its orientation. Still, others can measure the rate of change in strength and orientation over time. Robotic space probes can carry more than one type of magnetometer, with many subtypes of these devices existing as well. Magnetometers can work in different ways. The simplest use coils of wire, which, when passed through a magnetic field, generate an electric current. The voltage of that current provides information about the surrounding field. Other types of magnetometers calculate how magnetized a material becomes by detecting the change in an object's electrical resistance after passing through a field. Some magnetometers use ionized or energized gases to measure changes in magnetic field strength and direction. Early spacecraft typified some of these differences. The magnetometers carried by the Voyager 1 and 2 spacecraft consisted of two different types of high field magnetometer to measure very strong magnetic fields, and a low field magnetometer to measure weak magnetic fields. These devices measure magnetic field intensity along three mutually orthogonal axes simultaneously, and were used at different phases of the mission as the spacecraft drew closer to and then more distant from a particular target. Launched in 1977, at the time of writing, these magnetometers are still functioning and have provided extensive information about the magnetic fields of many moons and planets, as well as space beyond them. Many other spacecraft, including the most of the Mariner probes, Pioneers 10, 11, GOES, Europa Clipper, the Cassini, and Juno, to name just a few, have carried one or more magnetometers into the depths of space. Space probes are, by and large, made of metal, or metals, with many electronic parts. As such, the craft themselves generate a magnetic field. It's critical that any magnetometer placed on a spacecraft be unaffected by the spacecraft itself. What this means in practical terms is that, with rare exception, the magnetometer needs to be placed at a distance, or as distantly from the core of the spacecraft as possible. Now I'll just run this video here. There's a little video of this test happening. Let me just bring that up. We are there. Okay, this just goes for 2 minutes, and I'll kill the audio. Hang on, let me just run this and stop the audio. 1, 2, 3. Yep, still there. So what you're seeing on the screen right now is a probe, and they're just testing the magnetometer and how it gets unscrewed from the container. So let me just go back to the article. Many space probes make use. Actually, hang on. So what you're seeing here is a successful test. Successfully deploys the GOES satellite. GOES magnetometer boom prior to launch. So that's what you're seeing here, is the magnetometer being extended on its arm away from the probe, as the article is suggesting. Many space probes make use of long, rigid structures called booms to keep the magnetometer as far as possible from the main spacecraft bus or body. These booms feature predominantly in Pioneer 10 and 11, Voyager 1 and 2, Cassini and other spacecraft, while primary magnetometers are often placed at the tip of a boom. Scientists often place a second or even a third magnetometer at different points along the boom, so the magnetic fields generated by the spacecraft itself can be measured, subsequently factored out of the measurements. Magnetometer booms can be very long. The booms on Voyagers are nearly 43 feet, 13 meters long, and 9 inches or 23 centimeters wide. And the boom on Cassini's stretches out to 36 feet or 11 meters. While spacecraft... Okay, so that's finished. I'll just actually put that on a bit of a loop. Where are we? Just trying to find this video. Because I've got just a couple of more paragraphs to read. and I think I will put that on a loop so it just runs for a little bit longer. Alright, there we go. Yeah, so magnetometer booms can be very long, and just catching where I was left off, while spacecraft that only require short booms can use rigid rods for their magnetometer booms, longer booms tend to be more complex in structure, like lattice like structures, which is what you're seeing in the video here, and they can be compressed into small canisters to fit inside the launch shroud of a rocket nose cone. Once free of the launch vehicle, these booms are extended to their full length and become rigid, so they cannot be retracted, and that's what's happening in this video here as a test. Cameras aboard space probes are critically important, as they can show our eyes the wonders of the cosmos, but while scientific instruments including magnetometers are far less glamorous and garner a lot less attention, it is these instruments that enhance our knowledge and understanding of space in countless ways and are often the unsung heroes of space missions. So magnetometers, yes. And it's interesting to also, if you can, there are projects or magnetometers you can build to have associated with your station, and you can monitor the changes in the Earth's magnetic field during aurora, or even when there's massive solar flares, because once a solar flare hits the atmosphere, the magnetosphere goes for some pretty big turbulence, and your magnetometer can measure that turbulence very, very easily. You're tuned to ASV Radio VK3 EKH. Okay, we're broadcasting on, let me just get rid of that for a moment, on YouTube and Discord, and also on 80 metres and Melbourne Television Repeater VK3 RTV. Next article, let's get a move along. I can see we're already losing time here. This is an interesting article courtesy of astronomy.com. Inside radioisotope generators, the nuclear batteries that power faraway spacecraft. Now, there's a couple of things in here too that are associated with this one. So we'll bring up this image of Voyager again, another view of Voyager. Voyager 1, shown in this illustration, has operated for decades thanks to a radioisotope power system. There it is. Powering spacecraft with solar energy may not seem like a challenge, given how intense the sun's light can fill on Earth. Spacecraft near the Earth use large solar panels to harness the sun for electricity needed to run the communication systems and science instruments. However, the farther they go into space, the weaker the sun's light becomes and less useful. It is for powering systems with solar panels. Even in the inner solar system, spacecraft such as a lunar or Mars rovers need alternative power sources. As an astrophysicist and professor of physics, the author, not me, the author says, I teach a senior level aerospace engineering course on space environment. One of the key lessons I emphasize to my students is just how unforgiving space can be. In this extreme environment where spacecraft must withstand intense solar flares, radiation and temperature swings from hundreds of degrees below zero to hundreds of degrees above zero, engineers have to develop innovative solutions to power some of the most remote and isolated space missions. So how do engineers power missions in the outer regions of our solar system and beyond? The solution is technology developed in the 1960s based on scientific principles discovered 2 centuries ago, radioisotope thermoelectric generators, or RTGs. RTGs are essentially nuclear-powered batteries, but unlike the AAA batteries in your TV remote, RTGs can provide power for decades while hundreds of millions of billions of miles from Earth. And there's a little diagram here. Where's my VMix? This diagram. Okay, I think we've all seen one of those before. Radioisotope thermoelectric generators do not rely on chemical reactions like the batteries in your phone. Instead, they rely on the radioactive decay of elements to produce heat and eventually electricity. While this concept sounds similar to that of a nuclear power plant, RTGs work on a different principle. Most RTGs are built using plutonium-238 as their source of energy, which is not usable for nuclear power plants since it does not sustain fission reactions. Instead, plutonium-238 is an unstable element that will undergo radioactive decay. Radioactive decay, or nuclear decay, happens when an unstable atomic nucleus spontaneously and randomly emits particles and energy to reach a more stable configuration. This process often causes the element to change into another element, since the nucleus can lose protons. When plutonium-238 decays, it emits alpha particles, which consists of 2 protons and 2 neutrons. When the plutonium-238, which starts with 94 protons, releases an alpha particle, it loses 2 protons and turns into uranium-234, which has 92 protons. These alpha particles interact with the transfer energy into material surrounding the plutonium, which heats up the material. The radioactive decay of plutonium-238 releases enough energy that it can glow red from its own heat. And let me show you this. There's a picture here of that happening. There it is, look at that. The glow of radioactivity. It releases enough energy that it can glow red from its own heat. And it is this powerful heat that is the energy source to power the RTG. In this picture here, the nuclear heat source for the Mars Curiosity rover is encased in a graphite shell. The fuel glows red hot because of the radioactive decay of plutonium-238. Isn't that interesting? Radioisotope thermoelectric generators can turn heat into electricity using a principle called the Seebeck effect. Have you ever heard of this before? There is a more common name for it now, but it was called Seebeck effect. And I've got a video of this. Let me just run this video while I'm talking. I won't have... I think there is audio associated with this, but I'll just go over it. All right, so just follow the pictures. So in its basic form, the Seebeck effect describes how 2 wires of different conducting materials joined in a loop produce a current in that loop when exposed to a temperature difference. And this article here is talking about this. In fact, I might just run the audio, so just bear with us for a second. What I'll do, because it is actually interesting to listen to what's being discussed, so stand by. I shall just rewind this video and go back to the start. There we go. And I'll hit the audio button, and I'll just have to open this too. All right, I'll just turn this down.
Some of the most daring and exciting NASA missions exploring our solar system have become a reality thanks to a discovery made 200 years ago. In 1821, a German scientist discovered an unexpected property of physics. Metals and some compounds are good conductors of electricity as well as heat. The scientist, Thomas Seebeck, found that when he combined two of these materials and then applied heat to one end while exposing the other end to cold, a small electrical voltage was created across the materials. It turns out that electrons in the materials flow from the heat source, or the hot side, to the colder side. We now call this process of producing electricity the Seebeck effect. Today we use the term thermocouple to describe the hundreds of small pairs of junctions made from different conducting materials that take advantage of this property. We now know that the greater the difference in temperature between the hot side and cold side, the greater amount of power that can be generated. Inside a radioisotope thermoelectric generator, or RTG, these thermocouples are strung together in a long series so they can generate a steady current of electricity that can provide robotic spacecraft with the power they need to operate. Some of the specific materials used in RTGs are selected because they can conduct electricity as well as maintain a hot and a cold side. Seebeck used copper and bismuth in his experiments. Today we use lead telluride and silicon germanium. These materials are part of a family of compounds known as semiconductors. In the RTGs built by the U.S. Department of Energy and used by NASA, the hot side is provided by the heat energy emitted from the natural radioactive decay of plutonium dioxide. The hot side of the thermocouples can be more than 1,000 degrees Fahrenheit, or 500 degrees Celsius. The cold side faces out into space or into the atmosphere of a planet or moon, where the temperature can be well below zero. In addition, since no moving parts are involved, the thermoelectric effect is extremely reliable. Over the years, the thousands of thermocouples in NASA's nuclear batteries have performed without any noticeable failures in all of the 24 missions in which they've been used. For example, NASA's 2 Voyager space probes, powered by RTGs, have been carrying on steadily since their launch back in 1977. By using new, more Seebeck-friendly materials, the RTGs in development by NASA's RPS program and its partners in industry could be twice as efficient than those in use today. The invisible process of energy transformation from heat to electricity, discovered by Seebeck 2 centuries ago, continues to enable many of the most amazing NASA missions and discoveries, providing robotic spacecraft with the dependable power they need to explore some of the harshest, darkest, and dustiest places in the solar system.
Okay. Bring up my audio. Such big gain differences between running video and going to air. 1, 2, 3, 4, 5. I think there's audio there. 1, 2, 3, 4, 5. Yep. Okay. So wasn't that interesting? Seebeck thermal coupler is what we know them as. Anyway, so just getting my levels right here. So continuing on with this article, what you're seeing on the screen right now is an RTG, and which has a decaying material in its core, which generates heat that converts to electricity. Yeah. So in a basic radioisotope thermoelectric generator, you have a container of plutonium-238 stored in the form of plutonium dioxide, often in a solid ceramic state that provides extra safety in the event of an accident. The plutonium material is surrounded by a protective layer of foil insulation to which a large array of thermocouples is attached, as you saw in the video. The whole assembly is inside a protective aluminium casing. The interior of the RTG and one side of the thermocouples is kept hot, close to 1,000 degrees Fahrenheit or 538 degrees Celsius, while the outside of the RTG and the other side of the thermocouples are exposed to space. This outside space-facing layer can be as cold as a few hundred degrees Fahrenheit below zero. This strong temperature difference allows the RTG to turn the heat from radioactive decay into electricity. That electricity powers all kinds of spacecraft, from communication systems to science instruments to rovers on Mars, including the 5 current NASA missions. But don't get too excited about buying an RTG for your house. While the current technology, with the current technology, they can produce only a few hundred watts of power. They may be enough to power a standard laptop, but not enough to play video games with a powerful GPU. For deep space missions, however, those couple of 100 watts are more than enough. The real benefit of RTGs is their ability to provide predictable, consistent power. The radioactive decay of plutonium is constant, every second of every day for decades. Over the course of over 90 years, only half the plutonium in an RTG will have decayed away. An RTG requires no moving parts to generate electricity, which makes them much less likely to break down or stop working. And there's just one more image here which outlines kind of a diagram of what is on a spacecraft looks like, with all its bits and pieces. There we are, and I'll just finish off this last paragraph. RTGs have been key to the success of many of NASA's solar system and deep space missions. The Mars Curiosity and Perseverance rovers and the New Horizons spacecraft that visited Pluto in 2015 have all used RTGs. New Horizons is travelling out of the solar system, where its RTG will provide power where solar panels cannot. However, no missions capture the power of RTGs quite like the Voyager missions. NASA launched the twin spacecraft Voyager 1 and Voyager 2 in 1977 and take a tour of the outer solar system, and then journeyed beyond it. Each craft was equipped with 3 RTGs, providing a total power of 470 watts of power at launch. It has been almost 50 years since the launch of the Voyager probes, and both are still active science missions collecting and sending data back to Earth. Voyager 1 and Voyager 2 are about 15.5 billion miles, or 13 billion miles, nearly 25 billion kilometres from Earth, respectively, making them the most distant human-made objects thus far. Even at this extreme distance, their RTGs will still provide them consistent power. These spacecraft are a testament to the ingenuity of the engineers who first designed RTGs in the early 1960s. So I thought that was worth bringing into this discussion. You're tuned to ASV Radio, VK3 Echo Kilo Hotel, official station of the Astronomical Society of Victoria. I'm going to extend tonight's transmission because I can, because this next article about Firefly has just some interesting video in it as well, and I think you need to see this. Let me just bring up the image, the selfie that was taken. Okay, so that's Firefly resting on the surface of the moon and looking towards the Earth, not too far above the horizon. I remember seeing a stupid comment on Facebook, as you can imagine. Who took the picture of the spacecraft? I mean, what's going on? Immediately they don't realise that it's a shadow. They just don't see that. They think that's the spacecraft sitting there. So who's taken the picture of the spacecraft? What's going on? Conspiracy. It's fake. It's all fake. I tell you, people just don't use their brains. Anyway, so there it is. the shadow. That's a selfie. Anyway, quickly. Let's see. The Blue Ghost lunar lander finished surface operations on March 16, 2025, wrapping up a smashing success of a mission designed, built and flown by Firefly Aerospace based in Austin, Texas. Blue Ghost exhausted a flawless 2-month-long voyage capped by a stunning landing and 2 weeks of operations at the Mare Crisium. The success of the mission, named Ghost Riders in the Sky, presumably after the 1979 Johnny Cash hit, is all the more impressive as it was Firefly's first attempt at landing on the moon. Recent history shows that even 55 years after Apollo, robotic lunar landings are still risky and difficult. Just 2 weeks ago, Houston-based Initiative Machines IM-2 missions ended in a crash landing in a crater. The company's second consecutive landing also went sideways. And the landers from Russia, India, Israel and Japan have all crashed in recent years. On the other hand, all 4 of China's lunar landings have been huge success, and subsequent Indian and Japanese landings have achieved better results. Firefly's success right out of the gate is also welcome news to NASA, which paid the company some $93.3 million to deliver a suite of scientific payloads as part of the agency's Commercial Lunar Payload Services (CLPS) program. 4 CLP missions have now flown, including 2 Initiative machines. Of them, Ghost Riders in the Sky is only one that has been fully successful. And there's one more picture here of a sunrise, I suspect, or it could be a sunset. Deep, harsh shadows are created by the low sun elevation at the Mare Crisium landing site. Previews of the sun's illumination challenges facing Artemis astronauts at the lunar South Pole. That's what they say here. All right. I'm just going to see if I'll skip this, where I can skip things. Here's an artist's impression of the probe as it is on the surface of the moon. So this is generally what it looks like. After launch atop the Falcon 9 rocket on January 15, Blue Ghost did not dash directly to the moon like Apollo missions. Instead, it slowly spiraled out to the moon in a lazy, energy-saving trajectory before dropping into a lunar orbit on February 13. Over the next 17 days, the craft slowly lowered itself into a 100-kilometre circular orbit. March 2, the lander performed a picture-perfect autonomous landing near the Mare Crisium. This 620-kilometre lunar sea, as it's called, on the man in the moon's right cheek, was not explored by NASA's Surveyor and Apollo missions in the late century. Now, I'll just play this video here of the landing that went on. Here it is, this one here.
Blue Ghost Riders, Path to the Stars.
So this just goes for 2 minutes, but this is basically showing you the landing of the probe. So the probe's getting ready for coming in to land. A landing video released by Firefly showed Blue Ghost shadow becoming visible at an altitude of 28 meters as it slowly descended to the surface. Soon, an astonishingly violent swirling of dust storm whipped up by the rocket exhaust turned into a horizon obscuring haze. With shocking swiftness, after the engines shut down, the dust settled very quickly in an airless lunar environment to reveal a stone hurled towards the horizon, splashing into the dust to the left of the lander's shadow. I haven't really noticed that. Upon touchdown, and it's just about to hit the surface here, going by the video. Upon touchdown, the first of the 10 lunar surface experiments was already a success. NASA's Langley Research Center provided the stereo cameras for the lunar plume's surface studies. a 6-camera suite that recorded 3,000 frames of video studying how the blast from the rocket exhausted reacted with with the loose lunar dust and the rheoglyph, which I'll show you in a minute. Even half a century after the Apollo crewed landing, the dynamics of rocket exhaust impinging on the rheoglyph are not fully understood. And this is what you see in just a few moments. Yeah, okay. Now, there's a video after this. I'll just wait for this one to finish as it comes down, and then I'll just queue up this next video, which shows there's 4 cameras. So you can see this is the landing. You can see all the dust and see the rock. There's the rock. Yeah, there's a rock that gets thrown up into the atmosphere. There's no atmosphere, of course. But anyway, there's a successful landing, and everybody's applauding and clapping and carrying on and thinking, how successful is that? We all earned our salary for today. So it's excellent stuff. Now, I'll play this next video. This is 4 separate cameras that capture the directly below the probe as it touches down. So you can see it's picking up the gravel. It's really getting into the flames, are really getting into the rheoglyph and producing a lot of I don't know what you call it, but a lot of debris. And now it's finally landed, and yeah, so they've ended up with some dirty lenses, but that was directly below the probe as it landed. Quite amazing footage, that is. Now, the next footage is even more interesting because I'll kill the audio on this too. Right, going back to the article. Another fascinating experiment provided by the Italian Space Agency was the Lunar GNSS receiver experiment that investigated whether signals from global navigation satellite system like GPS can also be used to navigate on the moon. The LUGRE receiver was able to pick up signals from the US-run GPS as well as the Europe's Galileo system, both on the way to the moon and from the lunar surface. This shows that the same sat-nav signals that allow our smartphones to guide us to the grocery store can also help future lunar explorers navigate on the moon's surface. After the disappointing cancellation of the Viper missions, let me just check this video for a second. Right, that's not what this is it. Sorry, let me show you this one. Right. It was good to see Ghost Riders in the Sky perform 2 experiments that touched down and samplified the lunar surface. So what you're seeing here is soon after landing, the Lunar's Planet Vac LPV experiment prepared by Honeybee Robotics successfully demonstrated that the rheoglyph can be gathered into a small return container using pressurized nitrogen gas. And the collaboration between Honeybee and Texas Tech University, the lunar instrumentation for the subsurface thermal exploration experiment successfully drilled into the lunar rheoglyph. Now that just quickly came to the end of that video, but I'll just run it again. So yeah, so the image is so crisp and clear is what gets me. But here it is drilling, literally, blasting into the surface of the moon using nitrogen to do it. successfully drilled into the lunar regolith to place a temperature probe. So that's what it was doing. It was placing a temperature probe into the moon surface there. Fascinating video of the drilling operation showed rock chips and sparks being ejected from the pneumatic drill board into the surface. So mining activity has started on the surface of the moon. Amazing stuff. Okay, final image. And this one here it's a wrap. That's a wrap, they're saying. 4 days after landing, 8 of the 10 planned science objectives have been met, and the experiments were powered down to help cool the lander under the 250 degree or 121 degree Celsius lunar noontime sun. The experiments restarted later in the lunar day when the temperature had dropped. So what you're seeing there is the sun reappearing from behind the Earth during the March 14 lunar eclipse. Resembled a classic diamond ring effect as seen from the moon. However, the mechanisms for this diamond ring were not exactly the same as it appears on Earth. On Earth, it appears much larger in the moon's sky when the moon does on Earth. The ring effect is caused by sunlight refracted around the planet by its atmosphere. So, I think I'll leave that there. It just goes on for another paragraph, but I'll leave that there. If you want to follow up on this article, it's courtesy of astronomy.com. Just type in astronomy.com and go to the news tab and look for Firefly's Blue Ghost Lander nails lunar mission, because it really is interesting to see those videos. Okay, now I'll just touch on the space weather. That's the sun as if we could see it right now, and the solar wind is currently at 393.7 kilometers a second at a density of 20.31 protons per cubic centimeter. The sunspot number is 139, where the radio flux is at 170 solar flux units, measured at a wavelength of 10.7 centimeters. This is the current image of the aurora over Antarctica, and there's a little bit of a glow there, but not much to write home about as we speak. There's also a coronal hole that's facing Earth, which is known to be emitting high plasma particles, which can resort into solar flare activity. They say that it's a quiet sun. The chance of significant solar flare today is low. 5 sunspot groups are rotating off the sun's western limb out of harm's way, leaving behind an equal number of stable sunspots, all unlikely to explode, they reckon. And the KPT, K index, planetary K index, KP is currently 3, which is considered quiet. The 24-hour max KP figure is 3.33, which is also considered quiet. And just briefly, this is an interesting one. This is also courtesy of spaceweather.com. Let me bring up this picture. There it is. It seems at the end of the day that there is new evidence that cosmic rays spark lightning. Every second, almost 50 bolts of lightning zigzag across the skies of Earth. Despite centuries of study, however, researchers still are not sure how the bolts get started. Electric fields in the thunderclouds are often too weak to ignite a powerful discharge. But a new study, just published in the Journal of Astrophysics Research, may have solved the mystery. They say that we believe that the most lightning flashes in the thunderstorms are ignited by cosmic ray showers, says the study lead author Zhongmin Shao, a senior scientist at Los Alamos National Laboratory at New Mexico. And there's another image here, part of the article. To investigate the earliest moments of lightning formation, Shao and colleagues built a radio interferometer named BIMAP 3D, consisting of an array of 8 antennas in Los Alamos. BIMAP 3D can make three-dimensional images of lightning and pinpoint the bolts inside the thunderclouds. And here's an example. So those two pictures there are what they refer as a BIMAP 3D. The colours in the image represent time. The blue traces are the earliest moments of the bolt, while the red denotes the end. This is a lightning bolt from a massive thunderstorm that passed by Los Alamos on July 30, 2022. The BIMAP 3D imaged more than 300 bolts during the 90-minute storm. It was a treasure trove of data. The experimenters realized that some of the bolts were observed happened in parts of the storm where electric fields were too weak to cause the initial breakdown event, IBE, the initial spark that sets the lightning in motion. Modern theories of relativistic electron avalanche couldn't explain what they saw. Their suspicions soon focused on cosmic rays. Cosmic rays are high-energy particles that come from distant supernova explosions and other violent events across the cosmos. They strike Earth's atmosphere all the time, creating a secondary spray of particles called cosmic ray showers. And there's a little diagram here for that too, which we've all seen one way or another at some point in time. Cosmic rays strike Earth. Regular readers are familiar with these showers because they routinely monitor them using Earth's to sky cosmic ray balloons over California. One of the important things about cosmic ray showers is that they contain antimatter, positrons, as well as ordinary electrons. The Los Alamos 3D lightning maps contain strong evidence for the positrons. Electrons and positrons are bent in opposite directions by Earth's magnetic field, so they leave opposite imprints in the lightning polarization, which BIMAP 3D also measured. The author says, "It took me a while to figure out this," admits Shao. He says, I started with the electrons only at the beginning, but could not explain the observations. With both electrons and positrons involved, all the observations can be consistently explained. Positrons clinched the case for cosmic rays. The fact that a cosmic ray shower particles and ionized path in the cloud that otherwise lacks free electrons strongly favour the inference that most lightning flashes are ignited by cosmic rays, the authors wrote. In fact, it's still unclear how much of Earth's lightning is sparked by cosmic rays. Many more storms need to be studied with this method to improve the statistics. This will require a lot of long-term and good quality lightning data, Shao says. So that was quite an interesting thing, and more is to come from this study. That is for sure. All right, I'm going to leave it there. It's 11:23. I don't blame you if you've all left and gone home and gone to bed. That's fine by me, because I went to bed at 3 o'clock last night, so I'm very, very seedy. But somehow I've managed to waffle on for almost an hour and a half. So I think I've done very well. There is just one more article, but I'm going to leave that till next week, because this one is dealing with a new telescope lens. It looks interesting. All right, having said all that, you're tuned to ASV Radio VK3EKH with VK3CSJ on the microphone. I'll have just a quick look at email. There's been no more emails come through. Quick look at Discord, and I can see most of you are hanging in there. So good on you guys. Mike's left, but the rest of you chaps are still there. Let's have a quick look at the chat room. David's there. G'day to VK1UEB. Andrew there, VK3KIS. And yes, all right. Okay. Just say g'day to you guys. All right. Now let's just turn to the radio here and see if I've got no room for anything here. See if I can pick up if any stations wish to call in. And we'll see how we go. But I note that the streams are still hanging in there. Both Discord and YouTube are still working. But as soon as I start dropping off and letting you guys talk, I expect my streams to fall over. So if the image suddenly locks up, it's because the streams have fallen over. So basically, I'll make this the end of the session for tonight. Thank you for watching. I hope you found tonight of some value and interest. Anyway, let's see if there's any stations wishing to check in. This is VK3EKH listening on 3541.
VK3 Golf Lima. VK3 SPX. VK3 calling all hands.
Okay, VK3GL, VK3SPX, VK5, I think it was for Kilo Delta. Didn't quite get that one. VK3 Kilo Alpha Hotel. The VK5 station, can you try again?
Yes, VK5 Kilo Lima Delta, VK5 KLZ.
Yes. You are there on Discord as well, I think. Yeah, Les. G'day, Les. Welcome, dear sir. All right. Okay, Graham, have a say. VK3GL, VK3EKH.
Yes, good evening, Clint. VK3EKH and the group, VK3GL. Pleasant good evening to everyone who's checked in and called in this evening. Hearing everyone down here in Bunyip, 90 kilometres east of Melbourne. A good signal from you there, Clint, on 80 metres. It's been armchair copy tonight. I've been listening to you on the FT7. And audio sounds very nice through the FT7 receiver. So that's what I'm actually transmitting to you on at the moment as well. Yes, thanks very much for all the information you shared. I enjoyed listening to your commentary around the astronauts that have returned from the International Space Station. I've actually been following a little bit of the media discussions around that since they splashed down a day or so ago, and interesting commentary around how they've got to, or their recovery programs that they now have to go through in terms of getting their bodies back to accepting normal gravity. But it's not only that, there has been some discussions and some points raised about just simple things like the effects of weightlessness for prolonged periods on things like your eyes, and what the effect of returning to Earth and having gravity, the gravitational pull back on your eyes, things like your bone structure not bearing weight for some considerable time. So just interesting commentary around all the sorts of things that need to be considered, and it did take some time and some special rehabilitation to be able to get things back in order again. So there we be. I was a little bit busy at work this evening, so I didn't get an opportunity to listen to absolutely everything that I picked up on. A lot of the information that you shared about the astronauts in the beginning of the session tonight. Anyway, thanks for being there again on your normal Friday night. Much appreciated. Even if I don't get a chance to hear everything that you say, there are often bits and pieces that I pick up of general interest. So without you being there doing it, Clint, my knowledge wouldn't be any greater. Thanks again. 7-3, and we may or may not catch you over the weekend, I guess, on local devices. VK3EKH, VK3GL in Bunyip.
Yeah, no worries, Gray. VK3GL, VK3EKH. My streams are still hanging in there, I think. The video streams have not fallen over yet, so I'm glad to see that. I'm piping the audio of 80 meters over the streams as well, which is all being recorded too. So if you guys want to hear your signals and how they sound here at Narre South, just watch the video again. As soon as I drop off YouTube, you'll be able to fast forward through all the nonsense and go to the important part. Anyway, no worries, Graham. Yeah, good signal here too. And yeah, likewise, if you for those people who train to become astronauts and look forward to their first time in space, you know, it's if you're up there in space for just a short while, like 10 days or maybe a month, the effect on the body isn't so bad. But you know, once you're up there for up to an extended stay of 10-12 months or more, that's where the being in microgravity certainly has an effect on the body, and that's why all the astronauts up there have to do daily training. They have to spend at least up to a couple of hours a day doing particular exercises to keep bone strength and muscle strength happening, because really in a zero gravity environment the human body just withers away, and we'd all eventually become, if a zero gravity environment was to become the norm, we'd all become long, thin little creatures, which a lot of aliens look like. These long-legged, they don't wear clothes or anything like that. Anyway, oh dear. Anyway, but that's true, and that is the effect on the human body. And it's interesting to note that the astronaut, the lady astronaut that was up there, Sunny Williams, she apparently ran a marathon up there. The first marathon in space, she actually ran 42 kilometers on the treadmill up there. So there's a bit of trivia. First marathon in orbit. Anyway, I heard that somewhere, so I hope that's true. All right, thanks, Gray. We'll catch up with you throughout the coming week, no doubt. Steve, VK3SBX, VK3EKH. Have a say, mate.
VK3EKH, this is VK3SBX. G'day, Clint. Yeah, I'm afraid I missed most of the broadcast today. Clint, I was at a planning meeting with the Bendigo Club for the amateur radio electronics exposition we're having in Bendigo in May in conjunction with the WIH AGM. So I got back here to bearing up a bit pooped and sat down on the couch and turned on YouTube, and there you were on my feed. So I did watch it from the RTGs on, which that was pretty interesting actually. I didn't realise the plutonium would be glowing red hot the whole time. I guess the hotter it is, the bigger the difference, the more efficient it is, but must be pretty hard to handle that stuff and manufacture it with it all being red hot and all. But yeah, most interesting. And the Firefly landing, I think I've seen that before, but the way that dust just fell sort of like a rock, which it is, of course, with that atmosphere so quickly, was really counterintuitive and quite interesting. All right. Thanks, Clint. Sorry I missed you all. I did look, as I say, on YouTube, which has been hanging in there, and just got on to Discord in the last minute or two. Went up and I got on the radio to say hello. All right, thanks, Clint. We'll see you next time. VK3 EKH, VK3 SPX.
Yeah, no worries there, Steve. Good on you. VK3 SPX, VK3 EKH returning. Not a problem, dear sir. With with the football back in town, I suspect that if it's not going out to club meetings or council meetings, it's people watching football that would take people away from the important thing of listening to me on a Friday night, 10 o'clock. So that's okay. I can live with that. Yeah, no, not a problem. Look, tonight was pretty good. I found some very interesting articles, and I've left one out for next week, which is about a lens. It's really interesting. I had a quick read of it, and I'll leave it till next week. All right, thanks, Steve. Now, Les, VK5KLD. Let's see how we go. VK5KLD, VK3 EKH.
3EKH, VK5KLD, yes. Good evening, Clint, and thanks for doing the broadcast. I've been watching it for some time on YouTube, but it often annoyed me by dropping out and dropping in. So today I decided I'd get onto the Discord, and I managed to get it up on that, but I noticed it's gone to sleep or something. I don't know what it's doing now, but it doesn't matter. I saw all the broadcasts, and I was fascinated by that thermo couple with the radioactive element. I knew they did it that way, but I never actually seen one. It was interesting to see it. I was also fascinated with the magnetic test equipment that they had on the boom, and they kept winding it out. But, I take it the man in the desert boots and shorts, that must be the natural working test. But anyway, it was very good, and I watched a lot of the splashdown that was happening, and it was good to see them come back, and it'll take a while to get over such a period in sleep. Anyway, thanks very much, Clint. Like I said, I've been following your broadcast, as you saw, and there was no space weather woman today, but I haven't seen it during the week, so obviously she hasn't put anything up, but I've got a few of her talks that I watch every now and then. Anyway, all the best, Clint. Thanks very much for your efforts, and we'll be watching it again next week. VK3 EKH, and the name is Les, and I'm in Northfield in Adelaide, which is the northeast suburb. VK3 EKH, VK5 KLD.
Yep, thanks, Les. VK5 KLD, VK3 EKH. No problem, Les. So, welcome to the session tonight. Note that you've been listening on the odd occasion, and thank you for the kind words. And every Friday I always try to find some articles of interest. One, if I find them interesting, I suspect somebody else will. So it is. You can guarantee that on a weekly basis, there's always some interesting stories that come through. And I usually go from astronomy.com to space.com to sciencealert.com, and usually from those three sources I can find enough information that's of some value. The only problem is a lot of these articles tend to go for a long time reading wise, and I've got to try and cut them short a little bit. So that's usually when I say give reference to the article if you want to follow it up. I don't think I've dropped out. My indicator here on my vMix program tells me that everything is still streaming. So I can't really see the modem from here, but as far as I know, I'm still streaming. I haven't dropped out, so I'm not sure the reason why you might have lost the Discord there, but I think I'm still going to the internet. Yep. All right. Anyway, thanks, Les. Now we've got another station, VK3KAH. I think you're a first time station as well. VK3KAH, VK3EK, EKH.
To me there, Clint, VK3 calling all hams, or Charlie Alpha Hotel in Frankston, and moving everyone. And thanks very much for the broadcast. I got most of it. I sidetracked on about 4 other things there. And great there on the article on the, a couple of articles about the Voyager electricity supply. I don't think I want one of those around my shack there. It might make it glow in the dark. You won't need to turn the night light on when we get up in the middle of the night, I suppose. But I've never really pondered that. I knew they generated electricity somehow, but I wasn't quite sure where. It inspires me for a new article for the OTN or maybe the ROTC broadcast, which I've got to report tomorrow or the next day or whatever. Got to extract the digit. Got a whole pile of articles. And interesting about the, what is it, muscular atrophy of the astronauts. And I heard an interesting article about a month ago on the ABC about a bleaching of whales or similar type creatures on the west coast of Tasmania. They had to put about 90 of them down. Apparently, because whales were the mammals, well, just like us, I suppose, they live in a weightless environment, and for whatever reason, and no one quite knows why, these things beach themselves over on the west coast of Tasmania or on Farewell Straits on the top of the South Island of New Zealand or wherever there's gas beaching. Once they're high and dry, they're not in a weightless environment more. It's very, very painful for them. So that's why they eventually put them down. Unfortunately. Anyway, thanks very much for a very informative broadcast and good copy down here tonight on 80 metres. A VK3 EKH, a VK3 Charlie Alpha Hotel.
Oh, it's Andrew. Sorry, I had the wrong call sign. Yeah, okay. G'day, Andrew. And it is Andrew, isn't it?
Yeah, kill yourself.
Yeah, sorry, I had KAH, Kilo Alpha Hotel. I'd written down Kilo Alpha Hotel. I couldn't, yeah. Sorry about that. Yeah, you called in last week too. Yeah, g'day, Andrew. And as soon as you started talking about or making references to the RAOTC's newsletter too, I thought, hang on, I think this might be Andrew. Yeah, look, isn't that sad? Isn't it? It would be a marine biologist's thrill to be able to find out why these mammals do beach themselves, whether it be whales or dolphins or and it's always a mass beaching. It's not just one or two. But they all get into this mindset. Let's beach ourselves. It will be really interesting for somebody to study that. I suspect that there are probably some people out there that are studying this, but it would be very difficult, wouldn't it? Because it doesn't happen every week. So it would be interesting to be able to find out why. exactly, once they're out of their environment, it's the force of gravity acting on their body would be not very pleasant for them. So it would be interesting to find out the reason for that. I guess in due course, in due time, there will be somebody that will come up with the actual reason, and hopefully it will not be a man-made reason. Hopefully it will not be because of our actions with the environment that causes these creatures to do this, but rather something that's more natural to the environment, and hopefully that's what it might be. Anyway, we'll find out in due course, I suppose. But anyway, okay, Andrew, thanks for calling in, and good signal here. Like I said, the audio is being recorded on the YouTube feed, so you can always play back to hear how well you're being received here. Same with you there, Les. You can do the same. You're 5 for 9, Les. 5 for 9, and my noise floor is around S8, so a strength 9 signal is just on the noise there. But anyway, all right. Let's just see if there's any other stations that might want to call in. VK3 EKH listening.
VK3 Bravo Sugar Fox.
Oh, right. Go ahead, Pete.
G'day, Clint. Yeah, very interesting on all that stuff. And those RTGs, I guess they wouldn't work here on the planet because it's not cold enough on the other side of the thermocouple. Be hot enough on one side, but not cold enough on the other. Couldn't call it a battery, would you? It's they don't call it a battery. They call it a power supply. And okay, on your research into it, yeah, it must keep you busy. What sort of antenna have you got there, Clint? Your signal is a little bit better than what I'm getting here on my antenna. Go ahead.
Well, you're about 30 over 9, 30 to 35 over 9, and I've always ever used an inverted V for 80 meters, if that's what you're asking. Just a normal inverted V. The apex is up at 14 meters at the top of the tower, and one leg goes towards the north, and the other leg goes towards the south on the western side of the tower. So with that orientation, I seem to get a good signal out to the north and out to VK6 for any of the VK6s that might listen in. We used to get a couple of VK7s. There used to be a VK7 fellow that used to call in quite regularly. He's disappeared for a little while there. Anyway, but yeah, just a standard inverted V. Peter, go ahead.
Roger. Yes, I've got the same. It's up at about 40 feet, but it's going north-south, and for me to change that to east-west would... No, it's going east-west. Sorry, yours is going north-south. So to change mine to north-south would mean moving the mast. Okay, Clint, good stuff, and catch you again next week. I was watching the footy, and Collingwood had it in the bag, which they did, so I came over here. 73's to you and everybody else. VK3BSF, over.
Yeah, no worries, Peter. Good on you. VK3BSF, VK3 EKH returning. Yes. If I hadn't have had tonight's session, I would have been most likely watching the footy as well in the background, doing other things. I'm trying to get my seismometer that I've got here online. There's a little seismometer thing that I run. It's not in its ultimate position right now. It's just sitting on the floor of the barn, so just walking past the thing is enough to disturb it. But I'm trying to set up a program which allows me to actually view the seismometer readings on the internet. So I've been mucking around with that for the last couple of nights. So that's been keeping me busy. But I wouldn't mind getting a magnetometer running as well at some stage. As soon as I get my observatory down the back here up and running, there'll be a suite of scientific experiments that I'll have running So the seismometer and a magnetometer will be just two of those things. Yeah. Anyway, enough of that waffle. All right. Thanks, guys. Thanks, Graham, Steve, Les, Les, and and Andrew and Peter for calling in, and thanks for hanging in there and for the extended session tonight. And we'll do it all again next Friday. So this has been ASV Radio, VK3EKH, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast, concluding transmissions for tonight. I'm glad to see that the video streams seem to have hung in there. They haven't fallen over, which is really good. So we'll be back Sunday morning with the WI broadcast on 160 meters AM, 1825 kilohertz at 9 o'clock, and then again at 10:30 via the Melbourne television repeater, and then again 8 o'clock in the night. This is VK3EKH with VK3CSJ on the microphone, saying a very pleasant weekend to you all. Stay safe, and we'll be back next Friday. Cheers, everyone. Thank you for listening.
Cheers, 73 cents. All the best.
Okay. Just sign off in the book there, and turn that down. So thank you for all the viewers up there watching, and like I say, it looks like the streams have hung in there, which is good. So we've just got Steve hanging there on Discord, and I think that's about it. So no, I think I'll call it quits. I'm just getting tempted to play something, but I won't. Thank you for watching. We shall fade this out of view and bring up my call sign. Is that it? No, that's the insert picture. Where's my call sign? No. It's 4. Yeah. Oh, bloody vMix, I tell you. I mean, I love the program. vMix is a great little program for handling all the audio and video side of this station, but it's a bit fiddly with the key clicks. Anyways, that's enough for me. Let's cool down this repeater, and we'll be back Sunday morning. This is VK3CSJ concluding. Thank you for watching. Have a nice weekend. And I just can see there's an update there for vMix too, so I'll have to do an update. All right, enough of that. Cheers, everyone. Bye. Yes, Graham. Yep, no worries. No, I haven't been paying too much attention to my email, so I shall check it out in just a short moment.
He knows Lee, so I sort of
Oh, okay. Yep. Well, yep. All right. It'll be, yeah, as you said, just around the corner. So if he knows where Lee is, then that's not, it won't be any problem finding this place. That's for sure. All right. No worries. Thanks, Ray. No, it's great. It's good night from him, and it's good night from me. That's right. Sorry, what was that? Yeah, right. Yep, righto.